Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind75, a better blind 75 coding series. So today's problem is on construct binary tree from preorder and inorder traversal. That is pretty decent problem. So let's jump into the problem statement, understand it and start solving. Last time we have solved the unique paths. You can find it in the list. Let's start with construct binary tree from preorder and inorder traversal. Oh, okay. Congratulations, 50 days badge. Oh, great, guys. We have won a 50 days badge on Leetcode. Actually, I did record a few of the videos in advance, once or twice. That's why we are getting this badge on our 58th video. We can generate image. Okay, I'll generate image later. But yeah, that's like a good milestone. Okay, let's start. Given two integer arrays, preorder and inorder, where preorder is the preorder traversal of a binary tree and inorder is the inorder traversal of the same tree. Construct and return the binary tree. Okay, so this is the tree, for example, and preorder is 3 9 20 15 7. Okay, so we can see preorder means root is first, that is 3, then root left right, so 3, then left 9, then 20, then again 20 is the root for this subtree, so root left 15 and then right 7. That is preorder. In order, so in order is left root right, so we see left, that is 9, then root, that is 3, and then right, but then right again is a sub-binary tree, smaller binary tree, right? So again on this one we perform left root right, so after 9 3 on this one left root right would be 15, then 20, then 7, so 9 3 15 27. Okay, and in the end we have to return, we have to construct the complete binary tree and return in the normal format, which is 3 the children 9 and 20. Children of 9 would be null and null, for 20 it is 15 and 7. Okay, so how are we going to do this? Actually whenever we come to binary trees or anything with related to binary trees, we always go for recursion. So we take one formula, form it for the parent node, recursively do it for the left child and the right child. But if you notice, we have to notice few of the patterns, right? If you notice, this is a preorder, right? So that is root left right, so always the first element from the preorder has to be the root of the binary tree, right? So we can find out that okay, root of the binary tree is going to be 3, and if you check in the inorder, 3 is on this index, second index, that is 0 1, and on the left side it has only one element, that actually indicates its left subtree, and the right side indicates its right subtree. Similarly, if you find next root, subroot in this one, let's say for 9 for the left and 20 for the right side, from the inorder you can see for 20, left of 20 is the left child, right of 20 is the right child, right? So using these observations we are going to build our tree. Okay, so let's start. Please follow through the code and it will be much simpler to understand it. Okay, what do we need? So in order to keep a reminder for the index of the root from the inorder, let's create a map for that. Okay, we're going to create a map such that from the map we can store the indices of the elements in the inorder traversal. This will actually help us in finding the position of the elements. The key is going to be the element and the value is going to be the index from the inorder traversal. Okay, so we can say create a map to store the indices of elements in the inorder traversal. Okay, and this helps in efficiently finding the position of elements. The key is going to be the element, so the key is the element, and the value is its index in the preorder array. Oh, not from the preorder, we need this array, right? This one, that is inorder. Inorder array. Okay, so we'll create a map for this. Map integer in order map, okay, is equal to new hash map. Okay, now we'll traverse the inorder array and insert the values into the map. So we can say for int I is equal to 0, I is less than inorder dot length I plus plus. Okay, now inorder map dot put. So the value, the key is the element, right? So we have to insert in order of I, and the value is the position, so that is the index I. Okay, now we'll create a separate binary tree or tree helper class. Okay, so let's create that one first. Private tree node build tree helper. Since the main class is build tree, we'll call it build tree helper. Okay, now what all do we need to pass to this? We would need to pass our input arrays, so that will be preorder. Then we'll pass two indexes, the start index and the end index. Start index would be 0. We do not pass like this. We'll say int preorder. We need the start index, that is going to be int, let's call it pre-start. Similarly, we need the end index, int pre-end. We need the second array, int in order, then int in start, and similarly int in end. Okay, apart from that, we need our map as well. So map integer in order map. Okay, so we'll call this function from here directly. So we can say we'll call return, or before this let me put comments for everyone. We can say start the recursion or recursive construction. Okay, so return build tree helper. We'll pass preorder. Start index is going to be 0, end index is going to be preorder dot length -1. Similarly, in order, start index is 0, end index will be in order dot length -1, and then in the end our in order map. Okay, let me expand this a little for everyone. Okay, this is much better, right? Okay, now what are we going to do in the map? Let's have the base case first, where if the subtree is empty or the root tree is empty. Since we are going to call it recursively, we can say if the subtree is empty, right? So we'll check base case. If the subtree is empty, return null, because we are going to return the root from this overall solution. So if pre-start is greater than pre-end, return null. Now pre-start is 0 because we are passing 0. If our given pre-order is blank, that is 0 length, the end pre-end would be 0 -1. So pre-start would be greater than pre-end and we can return null, right? Otherwise, we'll find out the first element from the pre-order traversal, that will be the root of our current subtree. Okay, so the first element in the pre-order traversal is the root of the current subtree. Okay, as we know, in this case, from pre-order we can say 3 is the root of this current subtree or the current tree. 3 is the root of for this tree, right? So at least we'll find out the the root for the main tree as well. So we can say int root value is equal to preorder, preorder array, and we need to find the first start. Okay, since right now pre-start value is 0, let's do the dry run parallelly, right? So pre-start, the first initial value is 0, pre-end initial value is 1 2 3 4 5, 1 2 3 4 5 minus 1 4, in start value is 0, in end value is 0 1 2 3 4 5 minus 1 4. Okay, now after this, root value is equal to, in this case root value will be 3, right? Since pre start is 0, so we found the root value as 3. Let's keep root value here as well. Root value is 3. We found out for the main subtree or the main tree, the root is 3. Okay, let's move forward. So we can say, we can create a node, tree node root is equal to, how will we get the node? New tree node, and we'll pass this value, root value. Okay, now, so actually we are using this from here, we have this tree node class given. Okay, now we found the root, we need to calculate the size of our left subtree. Okay, we already discussed how we can calculate the size of the left subtree. Let me say it. Find the index of the root in the pre-order, right? First we will find the root in the Inorder traversal, the index for it. So we can say find the index of root in the Inorder traversal. Now we want to find the index for this root. We can say here, right, it is at index 1. But from where can we find it efficiently? We can directly get it from the map, right? So int root index is equal to, we already created a map for this, Inorder map dot get root value. Okay, so for this index we got the value root index as 1, right, since it is at the 1 index. Okay, we'll move forward. Now we already found the index for it, so we can calculate the left subtree for this root. So we can say calculate the size of the left subtree, right? So left subtree size would be int left subtree size is equal to root index minus start, right? Which start? Inorder start, in start. Okay, why? Because Inorder start is, if we see right now, is 0, root index we found out is 1, that is on 3, so 1 minus 0 is 1. So we know that there is one element on the left side. So size of left subtree for this root element is 1, and that is correct. We have only one element, that is 9, right? Let's move forward from here. So what have we found out as of now? We found out what is the root, we found out what is the size of the left subtree, we also found that means we know the size of the right subtree as well, right? So now we are going to call this build tree helper method recursively for the left subtree and also for the right subtree, because for this one we have constructed the root, we will construct the root for the left subtree, the right subtree. Okay, so we'll say recursively build the left subtree. How will we build the left subtree? Root dot left is equal to, so as of now we have only built the root index. You see, only built the root. You see, we have formed a tree node, we have built the root. Now we need to assign left child, left subtree, right subtree. So root dot left is going to be build tree helper. What do we pass? We pass the preorder. Now we pass the start index. Now the start index is going to move forward by 1, right? Because we have already covered the first position. So it will be pre-start plus 1. What is going to be the end index? End index is going to be pre-start plus left subtree size. Because now when we are building for the left subtree, that is 9, we'll pass the pre-start plus 1 since we already considered the pre-start, and its ending would be pre-start plus left subtree size. Left subtree size was only 1, right? So its ending is going to be only till 1. So in the pre-order, that is this one, we are saying the overall tree is going to exist only in pre-start, that is 0 plus 1. So start is going to start from 9, and then pre-start plus left subtree size. So 0 plus 1 is 1 also, right? So it is going to be this only, because it does not have any children. If you see, 9 does not have any children left side or right side. Its size was only 1 for the root. So its overall range will remain 1. Okay. We pass this. Similarly, we'll pass Inorder. Inorder will have the same start, in start, and the ending would be root index that we had already find. Root index, which is, how much was our root index? 1, right? So root index minus 1. Okay, from in order we can see there is 9. We pass the root index, that is 1. The start is going to be 0, that is 0. The end index is going to be root index. Root index came out to be 1, that is this 3, minus 1, because all the elements on this side is going to be for the left subtree. So for this, start and end is also same, that is 1 1. Okay, and in the end, of course, we'll pass our map. So we can say in order map. Oops. Okay, that's it. Now similarly, this is what we call for the left side. Similarly, we'll recursively build the right subtree. Okay, so same formula, root dot right is equal to build tree helper. We need to pass the preorder. We need to pass the start, right? Now if you see in the preorder, the start for the right subtree has to be this much, right? So we need to reach the value 0 1 2. How can we reach the start? So we'll give the pre-start, that is pre-start plus the left subtree size, right? Subtree size plus 1. Now if you see, pre-start is 0, left subtree size is 1 plus 1 2. So 0 1 2. We are starting from 20th. Where will we end? We'll end till the end, right? So end is going to remain same, pre end. Now similarly, we have in order, and in order will have the index, the start index for we can see for 20th, it is starting from here 15th. So we need to go till 0 1 2, right? How can we go till the start till 0 1 2? We'll say root index. We already know the root index, that is 3, right? So root index plus plus 1. Okay, and then end is going to be the same, and will go till the end. So we can say in end, right? And then of course in order map. That's it. That is how we are. So first we built the root node, how we found the root. Then we went on to build the left. We found out the root index. We found it from the Preorder traversal, that the root is 3. In inorder traversal, we found its index. We know all the elements on the left side of this is the left subtree. All the elements on the right side of this are the right subtree. So we recursively call for the root.left and root.right, and we modified the starting and ending conditions for the same. Now let's say like this, for root.left we call pre-start plus 1, that is 0 plus 1 1, pre-start plus left subtree, that is 0 plus 1 1. So when we come here, is it greater than 0? No. We'll get the new root node, which will be 9. It will not have any children. Okay. So this way overall the tree will get formed. In the end, whenever this all these conditions are done, we can simply return the root. Return root. So recursively it will form the left subtree, it will form for the right subtree. Let's see how it is going to perform in the left subtree. So for 9 we are saying root.left build tree preorder. Preorder is same, pre-start dot 1. So pre-start was 0. Now pre-start, when this method is called again, will become 1. So pre-start is 1. And pre-end would be pre-start plus left subtree size. Left subtree size as of now was 1. That was root index 1 minus instart 0 1. So pre-start plus left subtree size, it will be 1. So pre-end will become 1 for the root dot left from this root. Okay. Then in order is same. In start will remain same, that is 0. In end will become root index minus 1. Root index was, how much is the root index? 1. 1 minus 1, 0. So in end will be 0. Okay. Now we root value. Okay, it will get modified. Now we come here, this method is called, is pre-start greater than pre-end? Pre-start is 1, pre-end is 1. No. Then int root value is equal to preorder pre-start. Root value is going to be from the preorder, we are going to take pre-start. Pre-start is 1. So 9. So now we know the root value is 9, right? Because now every time the first root from the preorder is the root of the subtree. So 9 is the root of this subtree. So we got the root value as updated as 9. Earlier it was 3, now it is 9. Similarly, root index is inorder map dot get root value. So in inorder map we'll find the value for this index, that is 9, which is here. So the value will be 0. Okay, now left subtree size is going to be root index, that is 0, minus int start. So what is in start? In start is also 0, right? So root index minus in start is 0. So left subtree size is 0. There is no left subtree, right? Recursively, when we call the left subtree, this time we'll pass pre-start plus 1. Pre-start earlier was 1, plus 1 will be 2. And pre-end would be pre-start, that is 1, plus left subtree size, that is 0. So pre-end will be passed as 1. We'll come here, we'll see pre-start is greater than pre-end. Yes, return null. So its root left side will come out null. Similarly, right side will come out null, and this will be found and return as root dot left for this main root. Recursively it will call for the 20, then 50 and 7. Okay, I understand that the problem was slightly complicated, but once you understand, and once overall you understand how binary search tree or how the binary tree works, you can see why we always go with recursion. We form the formula for the root and then we recursively call the method. Let's run and test it. Let me bring this back to the middle. Oops, we have a lot of issues. Line 22. What have we done wrong? Inorder length. Inorder dot length cannot find symbol. Inorder length, which symbol you cannot find? Why is, okay, we don't need this. Okay, since it's an array, it stores the length. Now let's see, we are facing similar issue somewhere else. Inorder length. Okay, here also we have done the same mistake. Let's run again. Have we done it somewhere else as well? It's showing for inorder map. What's wrong? Variable preorder class solution. Inorder map. What's wrong here? Cannot find symbol. So we have the opening bracket, we have the pre-order, pre-start, then we had left subtree plus 1, then pre-end, then we had in order, then root index plus 1, then in end, then in order map. What is wrong here? Something is not correct. Is the spelling of our in order map wrong? In ORDER, in order map. Something is wrong. What are we missing? Variable pre-order symbol. Variable pre-order. Where have we used pre-order? Ah, this variable pre-order. Okay. Okay, let's see now. I hope we do not get any more compilation issues. Great. Let's submit. Okay. Okay, right. This is a good solution. Okay, so that's actually a basic approach for whenever we come to any of the problems on binary search trees. We always go with the recursive approach of building the binary tree. Okay, I hope the solution was clear to everyone, but in case it is not, please let me know in the comment section. That's all from today's video, everyone. Please for anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.